development processes, Waterfall, which is the more traditional, versus what this course is about is Agile. Waterfall is, it gets called a life cycle. It's basically a development process, but I was confused when they used life cycle like lifetime. That's not what it is. Life cycle is kind of the development process of software. We'll explain what Waterfall is, but this idea, you go through these steps and you're kind of like falling down a waterfall. That you complete a phase and you go on to the next one. Kind of sarcastically, it gets lumped into a couple other things called big design up front. Well, there's a lot of planning in this one, so that's another phrase you hear. So here would be the first step of the waterfall, requirement analysis and specification. You'd write this down. Before you write a line of code, you do the requirements analysis and specification. Then you do an architecture design, kind of what's the software architecture that's going to be. Still, you're not writing any code. Then you do the implementation. So you've completed the first two phases. Now you start doing the writing a lot of code. Now that that's been done, then you do the verification phase. Typically, and these phases often get done by different people. There would be some people doing the requirements, some people doing the architecture, some people doing the implementation, a separate verification or testing team. And then, and probably a separate group to do operations and maintenance. Now you've got it running, you're delivering it, people are operating it. So these are different, the program goes through these phases, and this is kind of the classic way that it's done. This is basically the way that hardware is done. And that's probably why software follows this model. Hardware absolutely gets the requirements, architecture design, implementation, verification, operation, and maintenance. This is the way hardware is done. So this is the waterfall model. And why did they do it this way? A lot of data suggests the earlier you catch the bug, the cheaper it is. If you don't get the bug until in the verification phase, boy, that's a lot harder to fix. If you could just get it by getting the requirements right, they'd save a lot of money. But this is, and one of the reasons they do the extensive documentation is these phases take a long time, and so people come and go. So a new person's on the team. How did they get up to speed? Well, they read the documentation. How well does it work? It really works well for things that don't change fast, right? So NASA spacecraft, we're going to the moon, you know, that's a classic one. Aircraft control, you know, the 747, you got software in there, boy, you really want very tight specs, and you don't, that's not going to change. On the other hand, a lot of the software that all of us use is this customer-facing software. Is you talk to the customer what they want, you'll hopefully get the experience in that class, and then you go away, you do the specs and all that, and you build it, and you get there, and that's not what I want. I want something different. So did you just end up with a bad customer? No, that's pretty common. The other thing for developers is they build it, they go through these phases, and once they're all done, they realize, now I know how to build it. Now, once it's done, and once I built the first, now I know how to build it. So this has got so as you'll see in the book, we do this a lot. We quote famous people. So Fred Brooks, who received the highest award in computer science, we don't have a Nobel Prize. It's the Turing Award, and part of it was for his really famous book, The Mythical Man Once in Software Engineering, said, plan to throw one away, you will anyhow. So that you try to build that first one, and the customers don't like it, or you figure out what's wrong with it, you throw it away. So that's what happens with the waterfall model. So another famous person, so they say it's kind of inevitable. Wow, if you write the specs and you build it, they're not going to like it. So what are we going to do? We're going to train customers, or what are we going to do? So this is Shimon Peres, somebody not often quoted maybe in this building, but not in this class. He's got this wisdom to pass on. He said, look, if a problem has no solution, you can't think of it as a problem, right? If it's a problem, we're problem solvers. If it's a problem, we got to solve it. He said, if it has no solution, then it's not really a problem, but it's a fact. Not to be solved, but be coped with. So there's times that things look like problems, they're really just facts, and you got to come up with a solution that doesn't change that assumption. So we can't, customers being unhappy with the requirements, you figuring out, that's a fact of life. So come up with another idea. So it turns out 10 years ago, a group of people frustrated by the big design up front thing where it wasn't working, they would build things and the customers didn't like it and it took forever, a manifesto like Martin Luther nailing the manifesto onto the doors of the church, with the Protestant movement. This is a movement. We're going to do things differently starting now. This is our claim. And this slide is actually what they wrote down, so I'll just read it. We are uncovering better ways of developing software by doing it and helping others do it. Through this work, we have come to value, and they got 4 principles here, individuals' interactions over processes and tools, working software over comprehensive documentation. That's a dig against the waterfall model. Customer collaboration over contract negotiation. You know, if the customers are going to change their mind, let's work with the customers. Let's not make sure, well, you can't change it. The contract says you can't change it, right? We're going to work with the customer. Responding to change over following a plan. So it's not the elaborate planning. It's going to be, things have changed, let's respond quickly. And then their bottom line, they're not saying the things on the right are valueless. He says, while we value the things on the right, we value the items on the left more. So individuals and interactions, working software, customer collaboration, responding to change, that's going to be the things we value, not that waterfall or big design up front model. So this agile life cycle embraces this change as facts of life. Continuous improvement, you're going through all these repeatedly rather than these big changes here, big phases. So you're continuously finding a working but incomplete prototype until the customer is happy, with customer feedback on every iteration. I'll show you what an iteration looks like. In the real world, it's probably every 2 weeks. In this class, you're going to get a chance to do this iteration a lot. We're going to make it 1 week iterations. We think the more iterations you do, the more you're going to learn and understand the process. And it emphasizes, and you hear a lot about this, Agile emphasizes test-driven development. You write the test before you write the code. To reduce mistake, user stories, that is, we're going to talk about user stories later in the semester, but basically you talk to the customer and you say, what do you want to happen with the software, and that is going to be the requirements. And a thing called velocity, where you measure how fast your team completes user stories, and so you're going to self-monitor. That's going to be the principles. If we go to, this is the tool flow, this is the flow of the Agile. This is one iteration that actually maps onto the chapters of the book. And you'll see this when you get the book. So you start off talking to the customer. We're going to split this test-driven development into 2 phases. The first phase is behavior-driven design and test-driven development. Those are chapters 4 and 5. Measuring velocity, you deploy it so the customer can see it. You talk to the customer again. That's fundamentally what the Agile flow is. You notice legacy is over there in chapter 7. Well, it turns out the same behavior-driven design can be used to enhance legacy. So the same technique you're using to write de novo code from scratch, you can use to tackle legacy code. We're excited about that. Now, another big idea in software is to have good software architectures. And one of the criticisms of Agile is maybe you just start doing this test-driven development. You don't think about the architecture. So there'll be a chapter that talks about the architecture, and you're going to be learning about how to do design patterns. That'll come up a lot, and you'll be incorporating design patterns when you're writing the code. But this is this is the Agile cycle, this so-called Agile life cycle, and that's what the course and book is around. And you'll go around this thing 4 or 5 times.